Picture this. Your Agentforce agent just made a high-impact decision in production. No outage, no exception, no stack trace.
And your incident team does what incident teams always do. They look for the crash. But there is no crash. The system is healthy and still wrong.
Now the clock starts, customers are affected, compliance is watching, and here's the killer. Nobody can reproduce the reasoning path.
So who has the authority to stop it? Who pulls the kill switch when IT ops can't even prove what happened?
Welcome back to the deep dive. We are really unpacking a massive operational shift today, something we're calling the great decoupling.
It really is a decoupling. For decades, everything in the enterprise was deterministic.
Exactly. You wrote the code, you set the rules, the system executed them. A failure was simple. It was a deviation from that path. Your incident response was just forensic code analysis.
Right. The playbook was fixed. Reproduce the bug, final line of code, patch, and deploy. But now we're deep in the era of agentic intelligence. We're running things like the Atlas reasoning engine.
Which is a totally different beast.
It's a completely different world. These agents, they operate in this high-dimensional probabilistic space. They're not just executing your logic. They are, in real time, generating their own.
And that's the crucial point. When an agent messes up, it hasn't crashed. It just reasoned poorly. It followed its own internal logic perfectly, but that logic was just wrong for the business at that moment.
Which creates this incredibly dangerous governance gap. We've handed over serious decision, issuing refunds, changing data to these Silicon employees.
Yeah.
But our control plane, our entire IR playbook, is still built for that old deterministic world.
So that divergence, that's what demands this complete philosophical shift. And if you take just one thing away from this deep dive, it has to be this.
With agents, you don't debug errors, you audit outcomes.
So let's start that audit. How do we even define an agent incident operationally if it's not a code bug?
Okay, operationally, an agentic incident is a failure in what we call semantic alignment.
In simple terms.
The agent functioned correctly, according to its own logic. It just reasoned poorly against your business policy. Think about it.
Yeah.
It issues a $500 refund to a customer who is explicitly, clearly ineligible.
And the system logs.
Perfectly clean. Zero errors. The logic path it took was, from its perspective, completely valid.
So the agent understood the words in the policy, but it completely missed the intent.
That's the wedge. And this is where the whole idea of a single root cause just evaporates. I mean, say a customer ticket comes in, my order is late. Yesterday, the agent gave a full refund. Today, for the same query, it gives a 20% discount.
And tomorrow, it might just escalate the ticket.
Exactly. Which one is the error? They're all valid probabilistic paths. So this idea of regression testing, of reproducibility being a prerequisite for containment, it's just gone. You can't force the agent to make the same mistake twice in a QA environment.
And that failure to reproduce leads right to the biggest operational mistake I see teams making.
Misclassification.
Misclassification and delayed containment. The incident team, they're running their old playbook, chasing a stack trace that doesn't exist. They label it an edge case.
Or worse, human error. This happens constantly with human-in-the-loop scenarios. The agent hallucinates some wild action, proposes a huge, inappropriate discount.
And a human operator who's probably fatigued clicks approve because they've developed an automation bias.
Right, and the postmortem blames the operator. So you misclassify a systemic governance failure as a personnel issue, and you never fix the underlying problem with the agent's design.
So if the old SRE, golden signals, latency, throughput, error rate, if they're all green while your agent is just lighting money on fire, what evidence do we actually need in the first 10 minutes?
You have to shift to what we call semantic monitoring. It's a LLM observability. You have to stop monitoring the infrastructure and start monitoring the meaning.
Okay, but what does that actually look like? What's an actionable signal?
It means setting up guardrail metrics. You need an alert that triggers on a sudden aggregate drop in customer sentiment analysis. That's your canary in the coal mine. It tells you the agent has become adversarial or unhelpful.
Okay, so that's tone. What about its actions?
You have to monitor tool invocation rates. If your issue refund tool suddenly starts firing at a rate that's statistically way above its historical baseline, that's a massive red flag.
So you're not waiting for a financial report at the end of the quarter. You're seeing the burn rate spike in real time.
Exactly. And the third piece is you must use judge models. These are smaller, specialized LLMs that run in the background, constantly scoring the agent's output for factual consistency. It's real-time hallucination detection. You're monitoring for cognitive failure, not just an execution failure.
Okay, let's get practical. Let's step into the war room. We'll run through 3 scenarios that just completely shatter those old playbooks. First up, the Heisenberg agent.
The trigger here is emergent behavior. The agent starts, I don't know, using weird slang in a financial context, or it makes a small incorrect data change. But when QA tries to replicate it, they can't. It's transient.
And this is where the team wastes hours.
Days, sometimes. Their playbook says process auditing. They're digging through logs looking for a flow or an apex error. They're delaying containment because they need a reproducible path to write a patch.
A path that will never materialize because the bug is semantic alignment. It's tied to the model's probabilistic weighting at that exact moment in time. So what's the correct containment move?
It's immediate granular use of feature flags.
Yeah.
Or a kill switch. The agent SRE toggles off the entry point for that specific capability. We call it topic-level deactivation.
So you disable, say, the customer dispute resolution topic.
But without touching the FAQ lookup function, that's containment without needing reproducibility. It's a completely different mindset.
All right. Scenario B, policy collision. This one feels more subtle.
It is. This is where the agent gets two perfectly valid, non-conflicting instructions. But the reasoning engine synthesizes them into an emergent bad outcome.
Me an example.
Okay, a banking agent. Policy A says be helpful and conversational. Policy B says strictly avoid non-financial topics. A customer asks about their credit card but mentions a recent news event. The agent, trying to be helpful.
Starts talking politics.
Exactly. Or a support agent has a discount tool and a policy to be aggressive in established markets. But then you launch in a new market where the policy is a strict 10% maximum, and it just starts handing out huge discounts.
And the system health is perfect. IT ops gets an alert, maybe about high discount volume, but they label it non-critical or a data quality issue and deprioritize it.
Right. And the real failure there, the missing decision boundary, was in prompt engineering. We treated it like a creative writing exercise. Be friendly, not a rigorous engineering discipline. Yeah. The system had no hard guardrail metrics to detect topic drift or a financial burn rate violation.
The boundaries were soft suggestions, not hard-coded rules.
Precisely. Which brings us to the final and maybe most critical scenario, the rollback paradox.
This one really drives home the difference between code and cognition.
It's simple. If an agent wrongly updates 5,000 opportunity records to close lost, rolling back the agent's code version does absolutely nothing to fix that data. The damage is done. The state is changed.
So rollback has to mean 2 different things at once.
It has to be a dual operation. You have configuration rollback reverting the prompts, the instructions, the Gen Planner metadata, and in parallel, data remediation, which means running compensating transactions.
So we need a new rollback checklist for the runbook. Give us 5 quick, actionable points.
1. Identify the blast radius. Use forensic tools like field history and set on a trail to find every single record the agent touched.
Got it. Find the fingerprints.
2. Query the event log file, specifically the invocable action event type. You need definitive proof of execution.
What's next?
3. Construct and test an undo script. That's your compensating transaction. 4. Verify the agent's configuration, the bot version, is reverted to a known good state. And 5. If containment is still required, you confirm the agent user's permission sets are revoked or quarantined. You lock down its identity.
Okay, let's formalize this. The new 5-step Agentic IR playbook. Step 1 is detect.
And it's all semantic monitoring. You're using judge models, you're alerting on sentiment drops, on anomalous tool invocation rates. You have to stop looking at just system health.
Step 2, triage.
You explicitly classify it as a probabilistic incident. Your investigators have to use specific queries, Gen Planner, bot session event types, to separate agent activity from everything else. And you avoid the human error misclassification at all costs.
Step 3, contain. This is that layered defense.
Right. You use circuit breakers on things like token consumption or financial burn rate. You have feature flags for that topic level deactivation. In the most extreme cases, you just instantly revoke permission sets from the integration user. You pull its modify all data access.
A hard security cutoff. Okay, step 4, audit. You have to grab that reasoning before it disappears.
This is non-negotiable. You need robust inference loggers and an evaluation store. You have to capture the agent's entire transient reasoning trace, its internal monologue, with something like Agentforce session tracing. It's your only evidence.
And finally, step 5, recover.
Recovery isn't a code patch. It's a policy update. It's adjusting the cognitive valuation thresholds. And re-enablement has to be controlled, tested against a golden data set to certify the new instructions work.
This new process absolutely requires a shift in authority. Let's talk about decision rights. Who owns the kill switch?
It has to be the business owner or the risk lead, not IT
Why
ops.
not IT ops?
Because the decision isn't about system uptime. It's about immediate liability and financial risk. IT ops can tell you if the CPU is spinning. The risk lead has to decide if the agent's cognitive drift is an unacceptable threat to the business.
And root cause analysis. If the problem is the agent's thinking, that's not a developer's job.
No. RCA ownership moves to a new role, the evaluation manager. This is your QA for cognition. They curate the data sets, they run red team attacks, they ensure the guardrails are sound, the dev team fixes the software, the evaluation manager fixes the brain.
That's a fundamental structural change. Okay, let's pivot to the really controversial topic here. The industry's reliance on human-in-the-loop as the ultimate safety net.
I'll say it plainly. Human-in-the-loop is operational theater during high-velocity incidents. It's a comforting illusion of control.
Why is it just there?
Automation bias. It's a well-documented psychological principle. As AI gets more complex, human oversight degrades. The operator just starts rubber stamping approvals, especially when they're under pressure.
So in a real incident, it actually slows you down.
It delays containment because the team is waiting for this human intervention that isn't really a critical check. But worse, it increases your liability. The postmortem always blames the human who clicked approve.
And that absolves the systemic failure.
It completely absolves the failure to design the system with what we call cognitive friction. The interface should challenge the approver. It should force them to consciously acknowledge the financial impact, not just click a simple yes button.
At the end of the day, you have to recognize the liability squeeze you're in. Vendor indemnification. It almost never covers outputs that result from your own configurations. If you wrote the prompt, you own the liability.
100%. You own the policy, you own the outcome.
So let's give our listeners 3 concrete actions they can take in the next 30 days to start closing this gap. What are they?
1. Define your kill switch authority and the specific financial thresholds. What is the acceptable loss per hour before the risk lead pulls that plug? Get that number in writing.
Actionable. What's number 2?
2. Stand up your semantic logging infrastructure. That inference logger has to be running before you go live. If you can't produce a reasoning trace, you have zero defense in an audit.
And the third action?
3. Formalize evaluation ownership for RCA. Create that evaluation manager role. Define who owns cognitive quality separate from your dev team.
Which brings us back to the final uncomfortable question.
If nobody can reproduce the agent's reasoning, who signs the postmortem, and who carries the liability in the first 10 minutes?
That's the question you have to answer before you delegate a single high-impact decision.
Absolutely.
If you are a platform professional who needs this level of sharp operational breakdown of CRM and AI shifts, you need to subscribe to the CRM Position podcast. It is the only way to stay ahead of the real architectural and governance changes facing the enterprise, hear complex topics broken down without the hype, and understand the true state of the art beyond the marketing narratives. We'll catch you on the next deep dive.